All right, so good morning, guys. We are going to be talking about physics today. Most of you guys, I know it's like really strange and all, but I'm going to be trying to keep it very similar to our regular class. So it's just easier for us to transition onto this online learning. So I'm going to continue on with the normal PowerPoints. Just make sure you're taking effective notes at home. I'm going to be also posting all of my videos through YouTube. I'm also going to be posting all of your work on Edmodo. Every single day there's going to be this attached to it, the lesson for the day. I'm going to put this, the link for YouTube as well, YouTube videos for you to watch to kind of help you and see this visually. Also, I'm going to be posting your weekly questions. So the weekly questions, there's two types. There's going to be the discussion questions and the lesson check questions. So the discussion questions are going to be due by Thursday. Thursday is going to be our official science day. So during our live session via Zoom, we're going to be talking about our discussion questions. We're going to review them, kind of talk about what all the material that I'm giving you through the week. To kind of review and wrap it up for Friday. So Friday is when your lesson check questions are going to be due. Now, the lesson check questions are going to be graded, so please make sure you answer them in complete detail. Please do not give me one-word answers. Make sure you're giving me enough information for me to really know that you know the material, that you're understanding it. Remember, you can always message me on Edmodo or on email. I'll respond pretty quickly. So let's get started. So like I said, we're going to be talking about physics. We also have this unit essential question. So how is energy going to be transformed and transferred from one object to another? So remember, you can always use CPOMs. If, for example, if you're really not understanding this and you don't want to contact me right away, you would go to CPOMs, you would go to the website, make sure to hit standards, type in these letters and numbers right up here. Then you are going to click on the standard itself. You're going to hit original student tutorial, and from there you're going to be prompted to go over take a video and some practice questions that you could do to get immediate feedback. So for this particular standard, we're going to be illustrating that the sun's energy arrives as radiation with a wide range of wavelengths, including infrared, visible, and ultraviolet. And that white light is going to be made up of a spectrum of many different colors. So if you, for example, have the textbook at home, match it on page 62 to 70. If you do not have it, it is okay. I didn't really expect you to bring it home. We didn't even know that we're going to be gone for this long. So just bear with us. It's going to be fine. I have enough notes on here to get you through the lesson. Like I said, YouTube videos, CPOMs, all of that is going to help you. So the electromagnetic waves. So you are going to be surrounded by waves at all times. There's many types of waves, including radio waves, microwaves, infrared rays, visible light, ultraviolet rays, and tiny amounts of X-rays and gamma rays. So these waves are all part of the electromagnetic spectrum. The electromagnetic wave in particular is made up of vibrating electrical and magnetic fields that can move through space at the speed of light. So the energy that electromagnetic waves transfer through matter or space is called electromagnetic radiation. Electromagnetic waves do not require a medium, such as air, so they transfer energy through a vacuum. This property makes them different from mechanical waves, which do require a medium. So mechanical waves are caused by a disturbance or a vibration in a medium, while electromagnetic waves are caused by a source of electric or magnetic fields. Those fields are produced by the movement of charged particles. Radar is a technology that uses waves, a type of electromagnetic wave, to detect objects in the atmosphere. So pretty much to put this in a little easier terms, just make sure you understand that electromagnetic waves do not require a medium. So a medium is something that they need to specifically travel through. So if you think of a vacuum, which not the vacuum you use to clean your carpet, for example, but a vacuum is just an empty space. So think about space. There's nothing in there. There's no air. There's really no gravity, nothing like that. So our electromagnetic waves are going to be able to travel through space. That's what it means when it says it does not need a medium. Now, mechanical waves do need a medium, so they need something to travel by. So, for example, sound requires a medium. So the only reason why you're hearing me or you listen to other people is because as I speak, our particles are vibrating in the air, and they're causing our ears to be able to detect the particle vibration. So, the practice model of light. So these, hold on, okay. So the wave model of light does not explain all the properties in the electromagnetic waves, but for example, when a beam of high frequency light shines on some metals, it knocks some tiny particles called electrons out of the metal. This is called the photoelectric effect. So these lower frequencies of light, such as red light, does not have enough energy to knock the electrons out. The photoelectric effect can be explained by thinking of light as a stream of tiny packets or energy instead of a specific wave. So each packet of light is going to be called a photon. For the effect to occur, though, each photon must contain enough energy to knock an electron free of the metal. One property of light that the wave model explains about the particle model does not is diffraction. When light passes through a narrow enough slit, instead of forming one image of the slit of a screen, it spreads out and produces a stripped pattern of light and dark areas. This is similar to a water wave passing through a narrow channel and then spreading out to the other side. So pretty much photons are going to need to have enough energy to be able to knock these particles out. So it needs to be able to knock these electrons. Electrons are negatively charged particles around us inside of atoms that need to have enough energy to be knocked out for this photoelectric effect. Now, wavelength. So if you use a wave model for the electromagnetic waves, the waves have all the properties that mechanical waves do. Remember that we talked about the the electromagnetic waves in comparison to mechanical waves. Remember, they do have the same parts per se, they're going to be a little different. I was showing you pictures of them through our slides. So, namely, each wave has a certain amplitude, frequency, wavelength, wave speed, and energy. So electromagnetic waves are going to be divided into a couple categories, including wavelength and frequency. So this is how the electromagnetic wave is going to be organized. So the first part of the electromagnetic spectrum, we are going to have our radio waves. Then we're going to have our microwaves, our infrared, our visible spectrum, our ultraviolet, our X-rays, our gamma rays. Now, all of these have very specific properties to each one. They have very useful things for each one of them. So if you tried to microwave your food, for example, with radio waves, or make a phone call with X-rays, you wouldn't get very far, right? Because every wave has a specific function for it, depending on their wavelength. So we have the longest wavelength is going to be our radio waves, and then our shortest wavelength is going to be our gamma rays, and I'll show you what that looks like. So wavelength and frequency are very related. In order for a wave to have a high frequency, its wavelength does be very short. If you want something to have a long wavelength, then their frequency needs to be very short. Make sure you understand that. Waves with the shortest wavelength has also the highest frequencies, and frequency is also related to the amount of energy it carries. The higher the frequency the waves has, and the more energy is going to be affected by it. Now, visible light is the only range of wavelength that our eyes are made to see. So anything else besides our eyes are not going to be able to detect. That is why we have the visible spectrum, which we can see all the different colors. All right. So the electromagnetic spectrum is composed of, like I said, all of these different types of waves. Now, the first one is our radio waves. So the electromagnetic waves with the longest wavelength is going to be and have the lowest frequencies are going to be our radio waves. So radio waves are used in mobile phones. Towers such as the one that we see out in the street, out in this picture right here, are going to be able to receive and transmit these radio waves along our network. Whatever you have, whether you have T-Mobile, Sprint, AT&T, anything like that, you're going to be able to get these radio waves. It's going to be able to connect our mobile phones to each other, to the internet and other networks, social media, things like that. So it's very important for our daily lives. Now we have microwaves. So a microwave has shorter wavelengths and higher frequencies than radio waves. Remember, it is in a, it goes in orders. The first one's radio, this is microwaves. So it's going to have a shorter wavelength, but it's going to have higher frequency, which means more energy. So when you think about microwaves, you're probably thinking of microwave ovens, but microwaves have many other uses, including radar. So radar is this little machine right here that cops usually use for looking at speed limit violations. So if you're traveling on a road, hopefully you're not going above the speed limit. Well, if you are, they're going to be able to capture that using these microwaves and give you a speeding ticket. So they're also used to measure the speed of a baseball pitch in baseball games. They are able to detect, like I said, speed limits. They are also going to be used for microwaves, conventional microwaves that we use also. So infrared and visible light are the next two. Infrared are going to be if you turn on an electric stove burner, so pretty much those flat top kitchen stove, you are going to be looking at infrared rays. So the invisible heat, quote unquote, that you feel is called infrared radiation. Infrared rays are electromagnetic waves with a wavelength shorter than those of microwaves. An infrared camera, for example, is going to be able to detect these infrared rays instead of visible light to take pictures, called thermogram. So this has also been used in video games. We have those specific lenses that can capture the heat of an object to be able to detect if a target's moving and something like that. Now, visible light we're all familiar with, of course. That is the only wavelength that our eyes are able to detect. So they're going to have a shorter wavelength but higher frequencies in infrared. So it's going to go right in order. Recall that light waves bend. They're able to refract when they enter a new medium such as water or glass. Now, light from the sun contains these electromagnetic waves of many, many different frequencies, both visible and invisible. And sunlight passes through a prism. You can see that it reflects a whole bunch of different frequencies, showing you this rainbow pattern right on that bottom right-hand corner. So after all of these conditions, these rainbows, as shown on this little figure, can also form in the sky. So if you think about after it rains, right? So it rains and we're going to see up in the sky. And most of the time, we are not going to really see this rainbow, but sometimes we will, because these light is going to be reflected by liquid in the air. It's going to be reflecting. It's going to act like this glass prism. It's going to split all these colors up, and you're going to be able to see this rainbow in the sky. So for today, I'm going to pause here. It is a lot of information. I'm going to do a couple slides a day, just like I would in normal class. And like I said, I'm going to be posting these on Edmodo. I'm going to be posting these on YouTube for you to have access, in addition to the questions that are going to be due, discussion, don't forget, are going to be due on Thursday, while our lesson check questions are going to be due on Friday via email, Edmodo, Word document, anything like that. So have a good rest of your day, and I will be posting these very shortly. Thank you.